So greetings, everyone. We're going to get started on the lab. Right now, the Lumidesk button is down. It's been up all day until about half an hour ago. I was working on it on my desktop. So this is where you normally want to click in order to access the programming environment. I have it open in an independent program called Anaconda. So the idea is you guys shouldn't have to install Anaconda, you shouldn't have to install Julia, you just have everything available, and you will really soon. And what we wanted you to do is to have stuff downloaded a little bit and play along with this as we go. And so John, you'll keep trying over there and you'll give me the big whoop and excited yell that we have reached contact with a Lumidesk, but we haven't. So let me introduce two people to start with. So the big guy standing over here, his name is John Pye, P-Y-E. So John is a sophomore in aerospace engineering, and he was in the pilot version of Rob 101 last semester, and he got no programming instruction at all. He just had to pick it up the way we were making all the students pick it up. And he still survived to tell the tale and move on. And then we have here, stand up, Lou, so everybody can see you. This is Lou Gahn. She's almost a doctor. She's already taken and passed her dissertation proposal. She's got a bunch of published papers in the areas of mapping, robot mapping, taking data and building awesome real-time maps with it. She's will be defending her dissertation probably in December. So she's like this far from being Dr. Lou Gahn. So they'll be working with us in the lab. And then the programming language we're using is Julia. And what we're going to show today is some simple things just to get us going. So we'll learn how you would use Julia as a calculator and how we can do some basic plotting and things like that. And we'll also write functions, because one of the things you want to do with a programming language is extend it. So a programming language allows you to have certain basic functionality. You can do sine, cosine, exponentials, all the stuff you would normally do on a calculator. But it's also set up to do testing, if, then, else. And so you can branch in your code structure. If numbers are negative, you go this way. They're positive, you go that way. And if it's 0, you don't divide by it. Okay, you can do all of those things. You can loop. You can do all sorts of things to extend the capability of the basic programming language. And so we're going to slowly build up our skills in this area and become acquainted with some of the thrills and perils, but ultimately satisfaction of programming in the Julia programming language. So the interface when we have a Lumidesk working will be very similar to this one here that I have in Anaconda. I guess everything is big enough to be read. And so we'll come back up and talk about what you can do in some of these various things. Now, when you get a file in Julia, you'll see that it's broken up into these things that are called cells. Okay, so these are places you can put commands. So those are called cells. I've already been running this one, so I'm going to do restart and clear output. Now I've just erased everything that has been done in this notebook. And you notice that there's these things called 1, 2, 3, 4, 5, 6. Those are called line numbers. Sometimes when you get a notebook, the line numbers are off. All you do is you go under View, you hit Toggle Line Numbers, and you get them back on. And we'll see that that's really important to know where the line numbers is, because when there's an error, Julia will tell you the line number. And you know, when I was first playing with it, I was counting the down on the lines, okay? That's not very efficient when it gets beyond 3 or 4, okay? So you want to be able to very quickly go to line 17 and know what that means and the cells, okay? So this is really so basic. To run a cell, you can just hit run here, and bingo. 4 plus 7.62 is 11.62. And you notice that that doesn't go 0, 0, 0. Huh. So if we do 4.762, and we do minus, well, what do we expect that number to be? Well, 11.62, Professor Grizzle. I actually finished 3rd grade, okay? So I've got that part down. And then to run it, you can go back up and hit this, or you can hit Shift Enter. Now, what Julia will always do is print out the result of the last command that is run. Now, can we see this number? And do we understand what is written here? So this is scientific notation, and the e to the minus 15 means that's 10 to power minus 15. That's little, okay? So that's numerically 0. So sometimes you'll be expecting the answer to be zeros, and you'll get, you know, 6.4, and then e to the minus 14, and minus this, and this, and this, and this, and this whole string of stuff. That's 0, okay? So one of the first things to get used to when you're doing scientific computation, 0 as an absolute concept does not translate perfectly into digital computations. Digital is 0 is a state of mind, okay? So if it's 10 to the minus 14, 10 to the minus 15, we're good. Everybody's welcome. Okay, so that's a small little thing. What do these pound signs do? What they do is they act as a comment and stops a piece of code from being executed. So if you want to test a couple of things, it's pretty simple. I just commented out that line I added, and now this is the only thing being executed here. The pound sign is turning off the code. And so we put a pound sign here so that we can then write text to help us remember what's happening. We're documenting our code, and also a way to help explain to you what we're doing. So that's what's going on all in this cell, which happens to be cell number 3. Now, if I run it again, it becomes cell number 4. And then if I run this one, what do you expect its cell number to be? 5, yeah. Okay, so good. So this is all real clear, right? We're just adding 2 numbers. Here it's a little bit different. You had to think about the same thing when you're doing calculators. So once again, this is not rocket science here. 4, 2 divided by 3, and then minus 1 times 4. And so what we're talking about here, we're not running. In case you just joined us, Lumidesk is down, but we'll get it up. We'll get it up. The Lumidesk people will get it up, and then we'll start running from there. So here, what we're talking about is the order of operation. Now, do you do 4 plus 2, which is 6, and then divide that by 3, and get 2, and then minus 1, and get 1, and then multiply that times 4? Is that what that line of code means? And the answer is no. There's precedence that happens here, okay? So in your mind, you might say addition and multiplication and division, they're all the same, but they're not in a programming language. And so it will go through and it will do the divisions and multiplications first, and then it will execute everything. Now, what a good programmer is probably going to do, in case you want to make sure that there's no doubt about what's going on, just separate stuff in parentheses. They may be extra, they may not be needed, but it's clear what's happening here. The 2 is being divided by the 3, and then you're adding that to the 4, and then you're subtracting 1 times 4, okay? So that's all that's being emphasized here. So that's just the same thing, and I just hit Control, Enter, and execute the code. So there's some reminders here about how it works, and so parentheses are checked first. Exponentials, 3 power 7, e to power whatever, those are done next. Multiplication and division are done, and then addition and subtraction is the lowest in the order. And so what we would love to have you do, and so maybe you guys can do this with a piece of paper and pencil. Place the parentheses in this equation so that the answer becomes 49. Give you a second to go through that. It'd be a lot more fun if you had a Lumidesk open. And the winner is not Rob 101, huh? Not quite yet. Well, Herbert, if this happens when you're teaching at Morehouse, you'll know what to do. Just reach into your back pocket, pull out Anaconda, and just power through. Okay, dude? Okay, so do we have it where we should put the parentheses here just to make sure that we get the answer of 49? Anybody got a solution for me? Do we add the 3 and the 5 and get 8 times 24? What do we do? I can't hear you. Oh, I have the answer. I should have hidden it completely. How about that? What's the answer now? So, question. Yeah, so we've got the answers here. So if we were running with a Lumidesk, we were going to first show you exactly how the homeworks would be. So when we're doing the grading of the homework, we're using an auto grader. Okay, so here's the correct order of the parentheses. We want to make sure we do the multiplication, then we add 3 and 4, then we divide by 2, etc. What this is showing you is the following. What we're going to be checking when we grade your answer, so let's just suppose you had done something a little bit wild and just said, this, I'm going to comment out the correct answer. I want a parentheses here. What do I get when I do that? Darn, that's 36, okay? But you go, well, I'm powering through. And so we'll have code in a cell that will check your answer, okay? And then what we'll also do on some of them is we'll go through and hand grade them, because you could say, okay, the goal is, whoops.
Can you check to see that the class is recording?
Tribby was working on that.
Tribby said that she didn't have permission.
Oh, well, if it's not recorded, I will record it in a cooler room with a Lumidesk running and make a good one. So I don't know. Okay, so you might just put in the, you might have just put in, x equals 49, and then guess what? Wow, the parentheses are wrong, but I've got the right answer. And if we just put a simple test like this, but we'll also go in and hand grade some of them and just check that you actually did the assignment. Okay, so even though it's an auto grader, we'll be a little bit careful. But what this will allow you to do is go through and you'll be able to kind of check things as you go. Okay, so this is supposed to be then a little bit more hands-on. And so let's see, what's going on here, John? I've forgotten. This is your first introduction to an autograder cell that fails. So let's see what happens here. So we run x equals 49, and then we assert, okay. So x is 49, and what we're testing for here, this is just showing you what does Julia do when x is 49, and we're asserting that x is 5. So the statement x equals 5 is false. Okay, so you get an assertion error. Where did the error occur? It occurred in cell 9, so this is really, really, really important. This is the cell it's in. And you're going, well, I'm not too surprised because I just ran this cell. But you could have functions that are being called, so it'll get a little bit more interesting as we go. But right now, yep, it's in cell 9. But then it's in line 3. Oh, that's where my error is. Okay, and if this weren't here, and we're really asserting x equals 49, then Julia is happy as can be, okay? So that's how you debug as it gets started, is which cell is it in? So it's now been renumbered 11. Each time I run this, it changes it. And it's in line 3. That hasn't changed. So this line is false. Questions so far? Anybody able to stay awake with all this heat and humidity, and is me being as enthusiastic I can as I'm dripping up here in front of you and feeling like I'm a melting candle? Okay, so that's just kind of using Julia once again in a fairly boring way, but it's just getting used to really the fact that we have cells. Cells are things you can write code in. It can have multiple lines. It can have hundreds of lines. You can have just a few things here, and that's a useful thing to be doing. And there's precedence of how calculations go. And then Julia is filled with already functions for you to use. So, you might have 4.7, and you want to just round it to the nearest integer. Quick question.
What is the difference between floor and trunk?
The difference between floor and truncate? It probably depends if it's a negative number or not, okay? That's where the difference would be. Because ceiling and floor are taking you to the nearest integer. Ceiling, C-E-I-L, is from ceiling, going up. Floor is going down. Round is ambiguous when you're at 0.5, okay? And I think it automatically goes up. You'd have to check the default. Yep, Monty. Yeah. So Monty says truncation just chops it off. Anything beyond the decimal point, but that's still giving you the rounding down if it's a positive, decimal. It'll take it to an integer is what'll be left. If it's a negative, then I don't think it's the same thing. So then absolute value, sine, cosine, tangent, arcsine, etc. And the only thing here to note is, how do you call arcsin? It's not ARCSIN, it's ASIN and things like that. Okay, so so there's a whole list of those things. And then when you get confused, you just get into Google and you go Julia basic functions or something like that. I should have done this to make sure what I was pulling up. And this is telling me how to actually build functions in Julia, not the sine and cosine and things like that. So that's what you get when you ad lib in the lecture. Okay, how are we doing online? Everything okay? Anything in the chat? Oh, got you, John's handling all that. Yep. Yeah, so here's some examples. And so if we have cosine of 2 pi, we get 1. But if we go, hey, 2 pi, that's 360. Oops, no, that's cosine of 360 pi, okay? So it's radians and not degrees. So if you forget, just check cosine and sine of pi, and then you'll remember very quickly. Exponentials, logarithms, if you've had calculus, these are functions you know. If you haven't had calculus, don't worry about it. We can hit run and go through these. And then let's see what happens if we put negative on the round down. So that's kind of funny. Yep, no, the ceiling, that rounded it up, so -1. And then let's check our question from the floor here. Yes, that's where they're different. I was right. Okay, so anyway, it's the minus sign on the floor and the ceiling. Oh, we want to do truncates. Let's do truncate here and see what happens. Was that TRUNC? Okay, so it just get rid of the 0.5. So that's how those things are different. So floor and truncated. Did we get this? Yeah, so floor went to -2 and truncate went to -1. So you can just get in there and play with them. And then here, the first thing we're trying to talk about is, okay, so the double quotes is how you deal with text. They're called strings. So you put the double quote marks around something, and it becomes an object that you can manipulate, which is kind of cool. But these functions that we have up here, they work on like real numbers. They probably work on complexes. If you've studied complex numbers, we're not using them very much in Rob 101. But the absolute value of hello, it should be what? Should be nonsense, okay? And that's what we get, okay? No method matching absolute value. And all of this stuff is saying, I don't know how to apply the absolute value function to a string. I can apply absolute values to other things, but I can't apply absolute value to a string. And the error was in cell 21, line 1. Yep, there's only one line. Whoop. Oh, our trusty assistant almost rendered us deaf, but we were falling asleep with all the sweat running down our brows, and he was doing us a favor of saving me from having my chin fall against the desk, okay? So, very good move, John. How are we doing here? Is this too slow? Is it just giving you... Should we go faster so you can get out of this room, or the pace is okay? Question. It's too slow? Too hot? Oh, that's a different answer. Yeah, so I asked the question of, am I going too fast or too slow, and I got a string as an answer in Julia, which did not compute. He said, no, it was too hot, okay? So that was perfect. Question?
It looks like a lot of this is familiar, it's pretty similar to the stuff that we learned for like MATLAB and C++ for Engineering 101. I'm not sure who else in this class. I'm not sure if there's anybody in this class who has not taken Engineering 101.
Well, I'm hoping that there's quite a few people here who are actually first semester and have not had Engineering 101. Yeah. Yeah, no, it's fine. So the question was, is all of this is so basic because it's also covered in Engine 101, which does C++ and MATLAB. And yes, so I think the first couple of weeks of the course, well, I'll get there 1 second. The first couple of weeks of the course, it's going to be where we're trying to all get on the same page, and at about the middle of week 3 is when things start taking off and we're doing triangular systems of equations and then LU factorizations, and then it's new for everybody. There was a question, another one. Yeah?
I don't know why there's some error.
Okay. Okay, so the question was, didn't quite understand why there's an error on the assert. And that was back here. So here x was, is this where you were asking? Yeah, so x is equal to 49. And what assert is doing is it's saying, is it true that x is identically equal to 4? Well, we have set x equal to 49. And so is it true that the value of x is identically equal to 4? And that should be false. And that's what the assert is saying. It is assertion error, x equals 4. If it had returned false, that would be even happier, just saying true or false, okay, is what I would like to see. But the error is that it is not true that this assertion is correct. Is that what you're getting at? Sorry, you're not, with these masks, people don't speak loud enough for me to hear you, so. Okay, oh. The very good question from the floor was, are the cells connected? Because you could believe you're computing in this cell, let's say, and it has nothing to do with the values in this cell. That would be a very logical possibility. So what happens is, as you execute cells, you are populating, call it the workspace, so a set of memory. Now, I could run cell 4 and then go down here and run something that I haven't done and then come back up and run. I would have access to the variables that I have run so far. So it's not necessarily linear in space, but normally, since you put the cells in a certain order, you typically execute them in time in a spatial way, cell 1, cell 2, cell 3, cell 4. So you have access to all of the cells that you have run up to that point. Does that make sense? Yeah, so you have access to the previous cells, but if you had gone down and run a cell and then you came back and did something, that could affect the calculation that you had there. Okay, so that raised another question. Wow, cool.
Well, I was going to say that Lumidesk does get something done. Yep.
Oh, no way. Oh my gosh. Well, at least we didn't just go home, okay? So, the Lumidesk. This is what's supposed to happen. Okay, so this is like you're at a race. Start my engine. Boom. My server's faster than your server. My server's faster than yours. Oh, go all the way. Yay! Okay. So John, under assignments, can we download? Okay, so this this is what your Lumidesk, now I've got a bunch of stuff because I've been working and getting things ready for the semester. Yours will typically come up and there'll be nothing here, okay? And you go under assignments and look, lab 1. What do you think happens when you hit fetch? Oh, wrong one. Did I already do lab 1? I'm already fetched it? Apparently, okay, so anyway, oh, yep, so lab 1. There we go. So now we've got it opened up and it looks almost exactly the same. It's not the same one as we had before. Because see, when in Anaconda, you don't have this assignments and stuff that you can then go to and download. And the key thing is once you have completed it, there's nothing to submit on this lab, but after you've hit fetch, you get to hit submit. And then Lou will grade it, and you'll mark them all wrong, right, Lou? No, she's got a heart of gold. Okay. And now I've run nothing. Our line numbering is going.
The assignment should be released for everybody, but it is not.
What was the question?
I don't think they've been added to the class.
There's no assignment.
We also are not registered.
Okay.
I'm going to look at their screen and see what.
Yeah. Okay, so the panic right now is I, as a professor, could download the files. John, as a TA, teaching assistant, can download it. Monty, can you download it? Yes.
I mean, at least for the sake of today, like I have the notebook. I just downloaded it from files on Canvas.
Yep.
And then just uploaded it. So
Yeah.
we can do it that way at least.
Yeah, you can do it, but we're trying to show how it's supposed to work.
Yeah.
And how it's supposed to work is not working. Is that frustrating to you? It should be totally frustrating to you. That's the correct answer. I want my money back, okay? This course is better than that. I didn't come here to be giving the worst lab ever, okay? I get the worst lab ever grade. Yeah, so you guys can access it. So this is our Canvas page under Files, Labs. And then you can download it, which is what I had done. So Lab 1, new copy, okay? So you can do that. This is not how you're supposed to do it. You're supposed to do fetch, but this will still work if you want to play along. Yeah, and then, oh. Okay, so now I want to, where is it at? Oh, there it is, over here, yeah. Go to upload, and then here's my Lab 1 new copy. I don't know why Julia does this, but it's in Anaconda and all of them. It uploads it to here, and now you've got to do a final up-click, and now it's there. You can order them, and there's the one I just downloaded the way that you could do it. Question?
What's the difference between a Lumidesk and Jupyter? They seem like kind of similar, like from a perspective.
Okay, the question is, what's the difference between a Lumidesk and Jupyter Notebook? So a Lumidesk is a service that allows us to run everything in the cloud and have all of our files in one place. And it's just executing the Julia programming language on a format, let's call it that, which is a Jupyter notebook. But you can run Jupyter notebooks in Python, you can run them in multiple programming languages. So it's kind of the Jupyter notebook is a, what is it, IDE, user interface, whatever, type thing. And a Lumidesk is this company. The nice thing about that is, I don't know about you, but I've got, a laptop that I use in class. I've got a desktop at home and a desktop in my office. If I do things on a Lumidesk, no matter where I am, all my files are in the same spot. Whereas if I run it on Anaconda on my laptop, I then have to save it to GitHub so I can then go access it when I get home. And it's just a real pain to keep track of everything, whereas a Lumidesk, it's all good. So that's what's going on there. And normally it works. Okay, so we had made it down to where? Enabled line numbering, we did all that. We did the assertions, many built-in functions, hello. Okay, so I think this is where we got going. And so once again, so there's 3 lines of code. We know that this one is not good. Absolute value of sine of 2, that looks pretty good. X equals x plus 2, that looks pretty good. The first time you execute something, it's slow. And then we go to cell 1, line 2. Cell 1, line 2, that's the problem. If I comment that out and rerun it, everything is perfect. I took the absolute value of the sine of 2 radians, and then I added 2 to it. That's it. Okay. Types. So this is something you never had to worry about in a calculator. And if you've learned MATLAB is very, very flexible on data types. So Julia, in this course, we'll be using primarily these 4. So there's this thing called integer 64, which are 64-bit integers. So if you do the binary representation, which we don't have to do anything in binary in Rob 101, but it's telling about how much memory space will it use to allocate to build integers. And if you can only use 64 zeros and ones, guess what? You can't get to Avogadro's number, okay? It just doesn't go that far. But now, if you're using that integer 64 and all of your calculations should be integers, you can keep them super accurate. You'll never have a 3.999999, et cetera, okay? So having your data types integers when you want your answers to be integers is very interesting. Floating point 64, so float 64. It's the same number of bits, but as we saw earlier where we had the 1.7, a whole bunch of stuff, e to the minus 15, okay, that's a floating point number. We can move where the decimal point is, and still that 1.7 ... that has the same precision, the 64 bits being used to represent that, or probably it's 60 bits to represent that, 1 for the sign and a few more for the numbers e to the minus 15. Okay, so it's allocating how memory is used, and Julia is being very careful with that. So these are integers when you want to do things like 1, 2, 3, 4, minus 17, etc. Float when you want square root of 2, 1.7 pi. Char is characters. So these are the things where you can do Chinese symbols, you can do all of the Hebrew symbols, etc. If you want to do things like that. The thing we'll use more is string when we want to keep track of a name for a class of something. So something that Lou does when she's working is called semantic mapping. Semantics means you associate a name to an object, so a robot will know that's a desk. And if you think about it, that's a pretty cool concept, okay? What Lou is mostly doing outside, and it's, hey, that's a sidewalk, that's a grass, that's building, that's people, that's light poles, that's dirt, etc. So she's associating names to what's out there in the real world, and then our robot's control system can say, I don't climb light poles, so I can't go here, okay? Or I don't want to be running over people, or I was told to stay on the sidewalk, and so I can reason and plan using that. So we use strings a lot in robotics and to do what's called semantic, which is just associating words to objects. Okay, that's basically the calculator stuff. John, at some point, do you want to take over, or do you think this is going okay? Well, you going to be prepared to do lab 3 mostly then? You see the style? Just be relaxed, and if things screw up, just go with it. Okay, so this is pretty cool. You want to build a new capability. I mean, this is not a super advanced capability, a line, okay? But you can build functions, your own function, and give it a name, and it's this simple, f of x equals. We'll show you how to build much more complicated functions a little bit later on, but this is a great start. F of x equals 5x plus 2. Okay, and then if we were to plug in x equals 3, so now this is really neat. X is a symbolic variable at this point. It hasn't been assigned a value. We're saying this function, when I put in a value of x, it does the multiplication and adds 2. You don't have to put the times sign even here. You can write it like humans do, though. If you put 5 times asterisk x, it'll be just fine. Okay, so let's do that. And then if we plug in 3 times 5 is 15, plus 2 is 17, and son of a gun. That's what we get. And f of 11, I don't know, that may be getting too big for me to compute. I got that one. And if I put in f of pi, what am I going to get, John? A big number with lots of decimal points, okay? So that allows you to extend already the language. 5x plus 2 was not a basic function, sine, cosine, ceiling, truncation. So you can imagine that it's perfectly fine for you to add a whole bunch of other terms to it, etc. But so as not to mess up what John has created for us, we'll keep it like this. John, we've already got these things defined, so we don't have to do the import on this. But normally, if you do your own Anaconda and you haven't used packages yet, you do have to import them, but we're not going to cover that. So we're just going to tell Julia that we're using plotting routines. So this is something in MATLAB you never have to do. MATLAB, you just get everything all at once. And your computer memory and disk space is just gobbled up by MATLAB, okay? Where Julia is trying to be very efficient and not take up all of the memory on your machine and waste it. So we're going to tell it to upload this thing called plots, and this is just a particular feature in it. And the first time you tell it to do that, it takes it a little while, and now it's got it. But now to plot this function, which will be very useful in homework 1, I mean, this is something I don't know how to do in MATLAB, but I'm pretty good at MATLAB. You just say plot the function, the lower range and the upper range. And first time it runs, it's slow. It's compiling all the code. And then the next time you run it, everything is compiled, and it just goes bang, bang, bang. And so you get your plot. And so if I were to go -8, now it's instantaneous because the plot function is already there. Okay? So you created your function, my function here, the lower range on the x, the upper range on the x, and then it just creates the plot for you. Now here, you know, it might be important to you. This is how big a 3 is, and look, this is 10 in between here. So this graph has, you know, everything is scrunched up on the y-axis, and now you can make those equal by setting aspect ratio equals 1. So that's cool. You can put x equals x label and y labels. This is just like MATLAB for those of you who've done MATLAB. Now what's different than MATLAB, once you've made a plot in MATLAB, you would say hold on, and then you would run another plot routine. In Julia, it's plot exclamation point, and it's read plot bang. The exclamation point is read as a bang. Why? I have no idea, okay? But I'm just giving you insight into the lingo of Julia. That's all it is, plot bang. So with plot bang, I keep the plot I had before and I modify it, okay? So I added the aspect ratio. They're now equal. I added the x and y labels, and I also plotted another function, g, that's identically 0 from -15 to 15. Now, if I had removed the bang, I get a brand new plot because of it's, okay, so the plot exclamation point adds to the previous plot. Plot without the bang, without the exclamation point, is a fresh plot. Okay, so now here's a suggestion. We've gone over a lot of stuff, right? And how are you guys going to remember all of this stuff? You can get good and start reading all of the Julia documentation out there, but you could also just put plotting commands in a Google Doc and then put plot gives me a fresh plot, plot bang, overlays on the previous plot, examples, and just start pasting the stuff in. If you do that, so if you go through this lab and you just build in the things that you're not going to remember, like, are you going to remember aspect ratio command, exactly how that's written? Are you going to remember when you do the function, do I put the -5 and 5 first and then the f for the function after when I do the plot, or do I put the function first and then the -5 and 5? The only way to remember the stuff is either do it a ton of times or create a Google Doc and build up a set of commands that you've used before. And so then when you're doing homework 3 and you know you've already done this stuff, you don't have to go back and looking, was it homework 2, homework 1, whatever, was it in lab 1, lab 2? Put your commands in a Google Doc and just keep track of stuff. It'll really, 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 really help you out. And getting a Google Doc is great because you can open it up everywhere and it's not saved on any particular device, et cetera. So that's what I would recommend. If you want to do it in a spreadsheet, that's just as good, okay? A well-organized spreadsheet could be fine. But, okay. I think I'm preaching too much, John. So this is what Mani was covering on class and lecture on Monday. So here's, simple linear equation, 2x minus y, another one, 4x plus y equals 4. And so we could rearrange them and write them as y. If I bring it to this side, I get y equals 2x plus 1. And it's the first equation, so I'll just create a function and call it y1 of x. Okay, so this is going to plot y as a function of x. And then this one's a little bit easier. I just move the minus 4x over here. So y2 of x is 4 minus 4x. So, okay, so we created these lines. We're going to plot both functions at once. Bingo. Now we could have done something very similar. John, I haven't tried this, but it better work, okay? If it doesn't work, you're in trouble. Oh! y1, and then I'm going to do plot bang of y2, and the only thing messed up should be my legend, right? Okay, and so my legend is not mixed up. I'll say legend equals false. Did I spell it right? I did. Okay, so instead of plotting y1 and y2 simultaneously, because I've never seen that before and I forgot, okay, I could just plot them one at a time, and because I use plot bang, I just overlaid them, okay? So there's always more than one way to skin a cat, as they say. This is very elegant. This is easier to remember and not screw up, okay? So which one are you going to do? Well, I'm into elegance, and I'm always going to do the more elegant solution. That's fine. I respect that. Okay, and then bingo. So we've got about 20 minutes to go. Should we take a little break here and just step out in the atrium and cool off? Is that what you guys would like to do? So everybody online, it's 80-something degrees here in this room. The humidity is probably 70, I don't know, maybe 90%. I mean, it's super hot in here. It's simply unbearable. I'm going to give you guys permission to just chill for a few minutes if you want. You can even take your laptops and you can sit in the atrium and I'll stay here and record, okay? It's okay. You're going to do that, aren't you? I don't blame you, okay? So there's a few people said, hey, that's the best idea that a professor has proposed to me all day long. He actually cares about me. So few people are going to move into the atrium and just follow the class online. So you're going to see a few extra people joining you on Zoom. Or you're just going to, disappear. Whatever you want to do. We're going to break for 5 minutes. We'll start again at 5:30. Okay, just go out, cool off. If you disappear, nobody's taking roll. It's all going to be recorded. If you want to come up and ask a few questions. That's great. You'll be recorded in the video, but maybe you're not afraid of that. Oh, man. Whew. Lou, you're the only one dressed appropriately. With shorts, okay? You didn't get to be a PhD student without being smart, did you? Why the air conditioning? There's some air handling system is broken. I don't know how long it's going to take to fix it.
So I'm saying why they are not registered on Lumidesk.
Oh, the students? I think Greg is messed up. He should have grabbed them from Canvas, but we'll make sure everybody's registered really soon.
I checked the students who were registered on the form grader, and it looks like everyone should be on there. But, I don't know how the login works for courses.
Yeah. Yeah, sure.
So for like the auto grader stuff, like what is it exactly doing? Like, because obviously, like, yeah, this is true, but like, what is that? Is it just confirming that it's true?
Well, no, because you see, okay, so the question is on these functions. So I'll go back up. So we wrote some functions. Now, let's suppose you had messed this up and you had it as x plus a half. You know, you just solved this equation and you just got it wrong, okay? Suppose you did that. Great, the plots look beautiful, there's no problem there, but you're going to fail all of these tests because your function at 0 is equal to a half and it's not equal to 1. So we're just going to plug in values that we know the function has to be, and then if your function, you left off a minus sign or something, yeah, that's how the autograder works, and we'll be giving you guys feedback on this, and also the way the homework is going to work is there's 9 homeworks. We're going to take your 7 highest scores for the drill problems and your 7 highest scores for the Julia problems. And so in the beginning, if you're messing up, it's no big deal, or if you have to make a trip for a student team, it's no big deal, etc. Yeah. Oh, they're wilting under my intellectual force, John. What do you think?
Something like that.
That's,
Maybe under the heat more.
what John just said is, that's laughable. It's the heat that's causing them to melt, Professor Grizzle, not your intellect. This stuff is not that hard.
It should be noted that in the regular autograder cells, so if you're actually accessing the assignment, thank you. If you're actually accessing the assignment properly, which is it's been published and you fetched it, you won't actually be able to see when those autograder cells fail. Those are going to be hidden tests. So you can't game it a little bit like that.
But we're trying to let you guys know what's under the hood, you know? It's like you get a car, you open it up, and you can say, oh, wow, that's really, there's no electric engine. All the motors are at the wheels. Question, yes? So, yeah, so what we really would like to have had is the compiled one and everything. When we'll give you guys some examples of that on homework 1.
I think it's possible that you might be able to access it. It seems like Professor Kapari is able to look at it.
So there'll be clues about where you are supposed to remove one line and then start putting your solutions in. And through help and everything, that will get you through the first couple assignments, and then it'll be just like, you know, 1 + 1 is 5. It'll be that good. Oops. Oh.
But you won't be able to see the tests. So what you'll see is that there is an autograder cell. It'll literally just say autograder cell, and then it won't show anything else.
Okay.
Sometimes we'll make a couple of the tests visible so that you have an idea of what the solution should be.
People online
Oh, yeah, of
can't
course.
hear you.
Sometimes we'll make some of the tests visible so you have an idea of what the solution should look like or what your variables should be named. But as you're looking through this lab, everything wrapped in begin solution or begin hidden tests, you won't be able to see. So you won't be able to see some of the tests, and you obviously won't be able to see the solution in the cell.
But in the end, we will make it where you can understand what you have to do, and we'll try to have 95% as the median. So you can just turn that on when you need to speak. Yeah. You're going to be like Ed McMahon on the Tonight Show here pretty soon.
Yeah, he's
Oopsie, where's the echo from? Oh, the mic. Yeah, no?
Yeah. We never did very good. I was really I want to pick it back up. I want to find another competition-based robotics thing. No, my last season was Turning Point. First, oh no! Wait.
Like the game was.
So did you go to Welch?
Once we all like 3 times. Turning Point is my first year.
Yeah. Maybe you guys should type it into the chat, for somehow it's coming over the room in a very garbled way. I'm pretty sure what you guys were saying was really cool. And it's just the way maybe it's the heat is affecting our hearing capacity. Yes, I feel like a baked casserole, yes. So, okay, we're back at it. In Julia, the basic thing when it comes to vectors is Julia likes column vectors. So Monty put things in a vector in lecture. 1, 2, 3, 4. You stack things up and you put square brackets. That's called a column vector. And Monty will go over this in lecture tomorrow. But he introduced these ideas roughly. That's a row vector. Do you want to turn on sticky keys? No. I'm turning on sticky shirt, sticky pants, sticky shoes, but not sticky keys. Okay, so Julia likes column vectors, so that's the default. It's a data type that the designers of Julia said, that's the default. So we still sometimes like to put things in a row. And so you can create things really quickly. You know, you could just type out row vector equals and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew, that was a lot of work, okay? And that's perfectly fine. You can do that. And I get a row vector. Fantastic. I'm here just calling it a 1 by 10 matrix, and we won't get into that subtlety today. But the other way to do it is this term collect just takes all the numbers from 1. You don't have an increment here, so it's really the same thing as 1, incrementing by 1 and going to 10. I could increment by 2, and I would stop at 10, so I don't get to 11. And then that apostrophe is what's called a transpose, and we don't cover transposes till like week 3, formally in the lecture. So this will be something that happens. We get a little bit ahead in the lab, and then we do it theoretically, or Monty gets ahead in the lecture, and then we catch up in the lab. So there'll be this little back and forth. But this collect gives us a column vector with the apostrophe as a transpose. It gives us a row vector. And you've got to do a lot of mathematics to understand what this word adjoint means. So don't freak out about that. That's like graduate level linear algebra, okay? Now, if you take Math 217 at the very, very end of it, they might cover what an adjoint is, but don't worry about it. It's a fancy word for saying I took a column vector and I made a row vector out of it. Okay, now, we'll go back to what it was supposed to be. I didn't specify my increment, so the default is 1. And then the autograder cell is going to just run it, and there's no problems. If I want to make a column, once again, I've already showed you, and you don't have to start at 1. You can start at 11 and go to 20. And you get a column vector. So the default in Julia is to build column vectors. And usually that's a good thing to do. So it's not that bad of an issue. Okay, so you can build vectors that way. But there's a bunch of other ways. So here we'll just show vectors can have things that are not numbers in them. You can build a vector that has strings in it. So this is a lemur type of monkey type thing, an elephant, a tiger, panda, zebra, and cuttlefish. I don't know why we like cuttlefish more than squid, but we've got cuttlefish, okay? So animals vector, that makes sense. It's got 1, 2, 3, 4, 5, 6 elements in the vector. Fantastic. Now what we're talking about here in indexing is how do you pull out an element from the vector? So I've got lemur, I've got elephant, I've got tiger. My panda, what we want to do is extract out panda from the animals vector, and it's at 1, 2, 3, 4. So my panda should be animals vector of 4, and let's see. Yay! I got the string in the 4th spot. And it's not, let's see, 1, 2, 3, 4, 5 characters. No, that's not how it goes, okay? So because we've got these quotes around here and the vector is being built out of strings, the panda is still the 4th element of the vector. And so my panda, and if I was to do 7, it's going to say, bounds error, attempt to access a 6-element vector at index 7. So there's only 6, and you tried to get the 7th one. No, 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 no. Okay, and then if we had done the 3rd one, it's, whoops, oh, it's because I got my brackets wrong. And I've got my panda equals a tiger. And well, with this kind of heat, I think that almost makes sense, okay? Question over here. Oh, so you're asking why is this not index 0 on lemur? Yeah, okay, so there's a very good question from the floor. So those of you who have some C programming, C is a 0 index language. It starts at 0. MATLAB and Julia are a 1 index language, meaning they start at 1. When you are used to one system and you change to the other, it drives you crazy for a couple of weeks. So we will give you a quiz, and we'll ask you to pull out the 3rd element, and you're going to say it's number 2, okay? But So those are the little things that will get you when you're going between C and Julia. Python is 0 indexed. Okay, so C, Python, they're 0 indexed. So the question for those of you going like, what's this indexing thing? Some languages say the first element of the vector is index 0. Now, when you're first learning a language and you're kind of used to whole numbers, you would go, that's 1, that's the first element, okay? So for you, Julia is exactly the language for you. This is the first index, that's the second, this is the third, this is the fourth, the fifth, and the sixth. So how do you remember that? You go to your Google Doc and you go, Julia is a 1 index language, okay? So that's what you will want to do there. And my Panda was 4, is that correct? Whew. Okay, and then Lemur, that's index 1. And we did this just specifically to help you guys get over those of you who have had some C programming and used to the 0 index, or you've done some machine learning and you played with Python, it's a 0 index. The first element of the vector is index 1. And so nothing too exciting there, getting over that. We're almost done. You can see the cursor, it's almost done. You can create matrices all at once. Julia has a nice command called ones. This is the number of rows. This is the number of columns. And yay! So that gives you a matrix of ones. It's not a whole often that you need a matrix of ones, but it's there. And I think this is a deliberate thing for you to find the mistake in the code. So we're going to get the size of the matrix, which is the number of rows and the number of columns. And then we're going to sum up all of the elements in the 0 matrix, but that doesn't exist, okay? So let's go ahead and run it and get the error on the books. 0 mat is not defined. So this is really supposed to be 1's mat. And then you add up all of the elements in the 1's matrix. There's 3 rows with 4 elements in it, so there's 12 elements, and they're all equal to 1. So 12 times 1 is 12, yay! So that's what that does. Sum adds up every element that's in this matrix that has 3 rows and 4 columns. And Monty will officially define matrices tomorrow. Question, yes, and then I'll get to here. What is there to do after this lab? The question is, what do you have to do after this lab? The answer is nada. There's no pre-lab, there's no post-lab. This is helping you to solve your first Julia homework 1. All the knowledge in here you will use, and that's due, it was posted next week, and it's due on Thursday of the 3rd week of class.
So, do we have to submit it or anything, or once we fill it out, is it auto-saved?
So on this lab thing, you don't have to do anything, you don't have to submit anything. This is a way for you to get some familiarity with the language, a barrier-free, we hope, entry into the Julia programming languages, the wonders of Julia. Yep, you're done, even before you came. And you're melting down. It's like the Wizard of Oz, the Wicked Witch of the West. Was it the water and she all melted? Yes, question.
When you made your matrix out with 1, why did you type out the word 1 and fill it with 1?
Yeah, so Julia has some commands, and it also has a command that's zeros, and you can make a matrix that's all zeros.
Let's say I wanted to put some other number like 5, 73, or...
Yeah. So then I would do 1s, and then I would put 73 times, and then I've got a matrix with all 73. There's still other ways to do it, but this is a way to get a matrix that's constant. So once you have 1, you can add anything you want, do anything you want to it. And there's so many ways and tricks. zeros, and if I do plus 73, so because I put a dot before the plus, it's going to add the 73 to every single element of the zero matrix. So there's just, like I said, there's so many ways, and if I didn't do that, Julia doesn't know what to do because you can't add a matrix to a scalar, but this operation overloads it and allows you to do this type of stuff. So there's many different ways. This is checking. If you've used the bell curve, this is the random curve right here of normal distribution. And I think the rest of it you guys can go on your own. Let's do this last one and just show that you can create awesome plots and things in Julia. And where's the Einstein figure, John?
Julia doesn't play nice with stuff.
Oh, okay. Well, we'll work on creating it. So you can even draw Einstein and things like that, okay? So with the plotting commands. And so look, it's just a few little lines and you can make really fun cycloids and stuff like that. So I think given the temperature, we'll stop here. I'll be happy to answer anybody's questions if you want. If you want me to answer them in the atrium where the temperature is 10 degrees cooler than here, we can do that.
Just to add one more thing on what Professor Grizzle was saying there, the dot operator syntax that he used to add 73 to the entire matrix, so that holds for all operators. So you'll see that at the bottom of the lab when we made that epicycloid, you'll see that we used cosine dot, and that did cosine to the entire matrix. The same works for multiplication, for division, for all the operators. So that's a fairly common error to see, is that you'll either forget to use the dot and Julia will just freak out because it'll think that you're trying to treat a matrix as a single value. When you see that, just use the dot and that'll fix the error.
Yeah, so we'll practice some of these more advanced things, but as John was saying, if you do cosine dot, it says distribute the cosine function to every element of this matrix. And so since they're all the same, I get the same answer, okay? But cosine is supposed to work on a scalar, and it can also work on square matrices, but that's a whole nother calculus trick there called Taylor series. So that's what's going on there. So mainly we did Julia as a calculator and plotting, and then a few things about data types, okay? And that'll get you through homework 1. And I think when you go through homework 1, you'll see, oh, all the answers are very similar to all the operations we've done here, so get you well prepared. And then we've got a lot of people ready to answer questions on Piazza, to Zoom with you, office hours, get you going. I think you need to call 911, John. The class is passed out. It's an entire class of unconscious people in here. Heat stroke, yep. Okay, everybody online, we're gonna shut down. We figure if we keep saying anything more, we're probably going to really mess up. So appreciate you being on here. And please give feedback as to how this worked for you guys, okay? Talk to you later. Bye.